Hi all, I am K. Surya, working as Assistant Professor in the Department of ECE at SNS College of Technology. In this lecture series, let us see about the characteristics of op-amp. The first video is about the introduction to op-amp. Op-amp in general, it is known as operational amplifier. An operational amplifier is an integrated circuit that can amplify weak electric signals. An operational amplifier is a DC coupled high gain electronic voltage amplifier with a differential input and usually a single encoded output. An operational amplifier has two input pins and one output pin. The basic role of this operational amplifier is to amplify and output the voltage difference between the two input pins. An operational amplifier is basically a three-terminal device. It consists of two inputs. One is the inverting input and other one is non-inverting input. The inverting input is represented by a negative sign and the non-inverting input is represented by positive sign. Apart from this, one more pin is the output port, which can both sink and source either a voltage or a current. This is the circuit diagram of an operational amplifier. So you consist of two inputs, which is the non-inverting input and the inverting input, which is represented by plus and minus, and the output is represented by V naught. And you have two supplies here. One is the positive supply represented by plus VCC, and another one is the negative supply, which is represented by minus VCC. So this is a symbol of IC741 op amp. What an op amp can do. An operational amplifier is not used alone but is designed to be connected to other circuits to perform a great variety of operations. Some of them are it enables substantial amplification of an input signal. So when an operational amplifier is combined with an amplification circuit, it can amplify the weak signals to strong signals. It behaves like a megaphone where the input signal is a person's voice and the megaphone is the operational amplifier circuit. For example, such a circuit can be used to amplify minute sensor signals. Processing of sensor signals can be further improved by inputting the amplified signal to a microcontroller unit, which is known as an MCU. So, as shown in the diagram here, when we are not using an amplifier or we are not using an op amp, your output will not get amplified and your signal will be weak at the output. When you use an operational amplifier in between the sensor and the output, your signal will get amplified and your output will be good. So next function of an op amp is that it enables the elimination of noise from an input signal. By operating as a filter of input signals, the operation amplifier circuit is able to extract the signal with the target frequency. For example, when an operational amplifier circuit is used for voice recognition or in voice recorder, it can extract the frequencies close to the targeted sound while shutting out all the other frequencies as noise. An operational amplifier can be tweaked to perform a broad range of functions such as arithmetical operations or signal synthesis. There are 8 pins in an operational amplifier as shown here. Uh, so the first pin is the input offset, and again the fifth pin is also an input offset. The second and the third inputs are inverting and non-inverting inputs, and the positive supply is given to the seventh pin and negative supply is given to the fourth pin, and we are not having any connection to the eighth pin. Output is given to the sixth pin. So it is the op-amp IC number is known as IC741 and it is a monolithic integrated IC. which comprises of the general purpose operational amplifier. So it was first manufactured by the semiconductor company named Fairchild in the year 1963. So the number 741 indicates that this operational amplifier has 7 functional inputs. 4 pins are capable of input and 1 output pin. Some of the basic terminologies of op-amp are as follows, which is slew rate. The slew rate of an op-amp is defined as the maximum rate of change of output voltage per unit of time. It is represented as volts per microsecond. Next is the output offset voltage. So output of the op-amp should be ideally zero when the voltage difference between the inputs is zero. But practically, the output is non-zero. There is a voltage of very small magnitude. This unwanted voltage at the output side when no input is given is called output offset voltage. Next one is input offset current. Uh, so magnitude of the difference of current entering inverting and non-inverting terminals. So when no input voltage is given to the op amp. Next one is the input bias current. And next one is input offset voltage. It is a voltage applied deliberately either at inverting or non-inverting terminals of the op amp to nullify the effect of output offset voltage. Next one is common mode rejection ratio. It is the ratio between the differential mode gain when the different signals are applied to both the input terminals and to the common mode gain when the signal is applied to just one of the input terminals. And the last one is supply voltage rejection ratio, which is known as SVRR. It is defined as the ratio of the change in input offset voltage of an op amp to change in the supply voltage V. Hope you understood some of the basics of operational amplifier. Let us take up some assessment questions. It's a dash type of amplifier. The options are current, voltage, power, and resistance. So basically, op-amp is used to amplify the voltage. So the answer here is voltage. Second one is the op-amp has dash inputs. The options are single, similar, zero, differential. So you know that the op-amp has 2 inputs. One is the inverting and a non-inverting. So it is known as differential input. So the answer here is differential input. Next one is op-amp has dash outputs. The options are single, similar, multiple, and differential. So you know that the op-amp has a single output. So the answer here is single output. Thank you for watching this video.